Hey guys, so today we're going to do a quick video. We're going to be going over a few things. Number one, I'm going to be installing more RAM into my main full node harvester slash farmer everything because I've been hitting RAM limitations when I'm running some plots on it. So I got myself 16 gigs more RAM, so we'll do a quick video of that, and then I'm going to take the RAM that's in there, put it into Viper, and so we'll increase that memory to 20 gigs, or 24 gigs actually. The next thing we're going to do is I'm going to be showing you a GUI plotting program called Harry Plotter. So good. And basically the reason for that is because I could not get SWOR Plot Manager to work with network share as the destination drive. So that was annoying, and that's just the way it has to be. So we're going to be going through that Harry Plotter review, and also we're going to be dabbling inside CPU affinity requests for plotting, which is going to drastically allow you to optimize each plot based on your CPU threads, allocating each of those threads to each task or job, and then having whatever separate ones working towards the other. So I'm going to show you how that works in Windows. SWOR Plot Manager also has that ability to do it within their configuration, and I'll show that to you too, because that's where I came up with the idea of doing it with Harry Plotter. So we'll go through those things real quick. On to the intro. This one's going to be a banger. Alright, so on the main plotting machine, we were running into a few memory issues. I was trying to use the GUI, which takes up a gig of RAM by itself, and trying to run two parallel plots. And I noticed that the RAM was hitting the 8 gig limit pretty much well. I don't know if that was a huge issue on the speed, but it definitely was basically hitting its absolute limits. So we went out, we purchased an additional 16 gigs of RAM, tossed them in. One interesting tidbit, apparently on some motherboards, there is a mem-OK button. Never seen it before in my life. I've built hundreds and hundreds of computers. Never had to use it before, but we installed this RAM, and there was a red flashing light. I didn't understand what was going on. It was compatible. It was the right RAM, exact same speed I needed. Everything. Ended up having to Google, and there is a little button there that turns red apparently when you install new RAM, and you have to press it on boot up. Really weird, but just if you're installing new RAM and you have an older motherboard, then most likely you may have to press this little button called mem-OK. Anyways, thank God for the internet, because I was able to find out exactly what the issue was, and we were back off to the races. Holy crap. I just did this whole video, and on OBS it was only taking a portion of the screen because I was in 4K and only displaying 1080p. So I did the whole thing, and it's all gone. So I'm having to redo this video, which is why I hate video editing and videography, but whatever. We're gonna do this, and it's gonna be a little bit quicker run through because my patience is running thin. But I have some really cool stuff for us today. Tested it, works, and I'm gonna get verification on the actual performance results after I've finished the testing. So the first thing I wanted to talk about is going back to one of my previous videos about the Farmer-Only install. One of the things that I forgot to mention is when you're running this Farmer-Only install on a machine, you have to change the Chia config to point to your full node. If it's set to localhost, it's not going to start up. So you have to point your Farmer configuration to the full node, which will allow it to connect to the full node as a peer. The other thing I added in the other video was the PowerShell script, which I created, that allows you to basically execute it, and then it kind of disappears and it's running in the background. You can set this up part of your Windows startup, so you can put this bat file as part of a startup, so that every time you reboot the computer, it automatically fires up the Chia Farmer-Only install, which I have done. So basically what we're doing here is I'm just going to do a quick review again on how to see if it's actually working. So we're going to stop this farmer, end task, and we're going to stop this Chia task. So this computer is .28, and we'll go to my full node, and we're going to take a look at my connections. All right, so my connections, I do not have a .28, but I do have my other farmers. So I have .14, .36, and where's another one? That's 192. Oh, I have to start up a few more. Okay, so this is good. So right now I only have 2 farmers up because I've been doing testing. So let's go and start this farmer. We'll just basically double click on the PS. You're going to see the Chia command execute. A second one will spawn, and then it will disappear, and it will turn into a start farmer only service. Now let's go back to my full node, and we should see a .28. So now this has started a farmer only install. Very easy with the script that I have, and you can add that to Windows Startup. So 3 things. 1, make sure that in your farmer only configuration you have the full node IP input. 2, you can put the PS in the startup. And 3, yeah, I'm verifying whether or not this is going to be as big as I think it is. Moving on to the second thing that I wanted to talk about is the automation of your plotting. So I just got into this, and I've been racking my head over getting Swar to work, because that is undoubtedly the most popular plot management software. I haven't been able to get it to work because I have a destination directory as network directory, and I've seen some workarounds that are pretty janky, but I always come up with the same error. And so I started looking at other options. What I've come up with is a new GUI based plotting software, which is called Harry Plotter, which is hilarious, amazing. And we're going to go through the configuration of that today. One of the things that I did see inside of the config for the config for Swar was it had the ability to enable CPU affinities, which is really cool and very important for something to modify this. So essentially what it says here is you enable CPU affinities, which gives you the hyper-threading cores that job is going to be running on. So if you want to run 1, 2, and 3 cores for one job, you can specify within the configuration the CPU affinity that you're going to be using for that one job. So, which is really, really important for optimization of plotting, because you know exactly how long your first phase is going to complete, and you know exactly which threads are going to be used. So once those threads are freed up after the first stage, you can reuse those in the second stage. So in this example here, I have thread 1, 2, 3, 4, and 5 set up. Yes, it's 0, but the 0 counts as 1. And then over here I have 5, 6, 7, 8, 9 for a 12-threaded system. Obviously, I wasn't able to get Swars working, and to be honest, I don't think I need it. I've done some testing with this Harry Plotter, and it seems to be working well as he's actively developing new features, advanced features, and he's very active on Reddit. So I hope to be working with him and sending some information on how to do it. But this section here has given me an idea on how to implement affinity requests within plotting. So now what I want to get into is a little bit about Harry Plotter, which is a GUI-based plotting system that's fairly new. Let me see, I don't have it up on this one. So essentially it's, you can set up your tasks or jobs on the left-hand side here. You give each job a name, temporary directory. It's very similar to the GUI, only much better. So I did a test of the Chia GUI doing plots, and I did a test of Harry Plotter doing plots, and it was about, I think I had 6 plots done before the GUI had done 1. So it's quite quick. I haven't tested it against Swars because Swars doesn't work for me, and I'm not going to go there. I don't even care how to fix it anymore. So one of the cool things is it has a real-time log viewer here. So during any job, it continuously updates this section here with the tailing of the job, the log, and it gives you the average information for this task. So plots created, we did 3 plots. Each plot average took about 6 hours because I haven't done any tweaking to these boxes or anything, as well as I didn't do the Affinity request, which I'm going to show you guys. So it shows you all the information here, and if you need to find out what phase or what section you're in, you can just copy all of these logs and paste them into a log viewer here. So AV, and then you can take a look at the last setting and say, okay, phase 1 of 4. And then you can actually search for phases and find all in current document. Okay, so phase 1, and then this was, okay, so I've only done 1 phase with this one here, but you get what I mean by being able to scroll through the logs pretty easily. So let's go back to talking about the Affinity requests. Basically what that means, again, is you allocate specific CPU threads for that process, and then it only uses those threads. Before we get into the Harry Plotter stuff, I also wanted to indicate something that I'm testing out, which is partitioning a drive. So when you plot, you obviously get, it uses about 256 gigs of RAM. That sometimes goes over and sometimes it goes under. So when I was testing my plotting with the node, with the full node in the GUI, I had 2 plot sessions. Plot 1 was plotting on this hard drive, which was 238 gigs, and plot 2 ended up failing on this hard drive, which was 223 gigs. What I noticed was the plot 1 didn't actually even come close to filling up the 238 gigs. So plot 2 did, and in fact it stopped because it filled up the whole drive. So I think there's a variance there between how much space it actually needs, and I don't know what those variables are, whether or not it's if you can set it at 228 or 230, depending on what it does. I think there should be a more defined way of saying we need exactly this much space. So either way, I was trying this through the GUI just to see plotting on 2 separate drives, and these are 2 separate NVMe drives. So I got the idea of taking a 1 terabyte NVMe and splitting it into 4 separate drives. The reason I decided to do that was because a mechanical drive, if you split and partition the drive, the head still has to move back and forth. So it actually is worse because it actually has to take time to move the head from one partition to another. But that physical head has to keep moving if you're copying to one partition or another partition. With a RAM drive or a NVMe, it just basically can sequentially choose those areas of the memory to select. So I have a feeling that this is going to allow us to plot a little bit faster if we have the defined spaces up for it. So what we're going to try and do, because when you plot you have so many temporary files, that I was plotting into folders just to keep the files in sort of a cleanly way, and if one job doesn't work, you can delete that folder, as opposed to if you have all of the temporary files in one folder and the job doesn't work
and it doesn't clean out the temporary files for that job, you have no idea which ones to delete. So it's just a mess. So this allows you to kind of say, okay, here's job 1, job 2, job 3, job 4. So right now we're going to open up the Harry Plotter application. Very easy to install. Just go to the website that I'm posting in the description, and you'll be able to see how it's set up, how it's installed. It's literally just extract and start. This is what you're faced with here on the Harry Plotter setup. You can edit your staggering, so how many plots in phase 1. I'm saying 4. How many maximum plots in phase 2 to 4, 4, and the stagger time 60 minutes. So each one of these plots is, you give it the name, the temporary directory, your destination directory, and all the typical stuff that you want to be able to do. Each one of these I have configured to go to the different drives that I've partitioned, and those hopefully that will render in a cleaner temporary file cleanup. The GUI doesn't actually delete the temporary files. Harry Plotter does delete the temporary files, so that's really good. And you can hard stop the task. You can stop certain ones or stop all of them. So we're going to get into the Affinity section now. So what we've done is we've opened up Harry Plotter, and here is the task. In order to set certain CPUs for that task, you have to right click on the task, go to details, then it gives you the PID number and Harry Plotter. So you're going to right click on that specific task. We're going to set the priority to high. Yes, I'd like to change the priority for this application to go to high. Then we're going to set the affinity. This gives us a list of all of our threads. So there's 12 threads here. So for this one specific task, I'm going to be running one plot. I want it to take up the first 3 CPU cycles. And we'll say, okay. So now, if I was to execute this, even if I have 4 or whatever number I put in here, it doesn't matter because it's going to be overwritten by the Windows task. So, I mean, we'll just put 3 here for the shits and giggles. It doesn't really matter. So let's execute this. Start. If you take a look at the performance, it's going to be using these 3 CPUs. CPU 1, 2, and 3. So that's pretty cool that we get to actually specify which CPUs to use, because we know exactly how long phase 1 is going to be. We can reuse these CPUs right after that phase is done. So it's at, I think it's at, what is it at here? That's not quite 100%, but we'll make it 100% for the next one. So if I want to go ahead and, unfortunately, I can't allocate CPUs in here. It says the number of threads, but they're random, and I don't know how it selects them. So we're going to reopen another Harry Plotter, run as administrator, and we're going to select plot 2. Again, it doesn't matter. But now that I have 2 Harry Plotters, we need to go back and set the affinity for this next one to use CPU 3, 4, and 5. So let's take a look at Harry Plotter 2. Let's go to details, and this is the second one, I think. So this is why you have to actually keep remember the task. Okay, so no, it's not that one. This is the new one because we don't have the priority set to high. So priority set to high, yes, and then let's set the affinity request here to 4, 5, 6. Okay. We're going to be doing the E drive, and let's go ahead and start that one. Take a look at the performance. We got CPU 3, 4, and 5 all going now. All right, let's go ahead and do that again for the next one, which is really cool. We could probably fast forward this. This is just me showing how it works. Plot 3, we've spun up a new Harry Plotter. Let's go take a look at the details. Here we go, 2864, set priority, high, sweet. And now let's do the next set of, so 1, 2, 3, 1, 2, 3, and then we want 1, 2, 3. Okay, here we go. plot 3, start. And again, now we're using CPU 6, 7, and 8. So this gives us a really good ability to micromanage every single thread, because it's going to tell us how long, I don't have the information here because I just started it on this one, but it's going to tell us how long our average time is, our average phase 1 time is, and whatnot. So now that we know phase 1 on this computer is going to take about 2 hours. So now I can say, all right, in 2 hours, I want to reuse these cores. This one, this one, this one. So I can set up a list of tasks for those cores specifically to execute basically in 2 hours and always be using the cores. So that's really, really cool. And here you can see that my 3 plots are being plotted to. So if plot 3 fails, I just go to plot 3 and say, okay, delete these temporary files, and that's that plot. That's fine. So just for giggles, we're going to do one more. I'm just going to do my final one here. May as well. And we're only going to do 2 cores this time. So I'm going to go to plot 2. Let's take a look at the process. Harry Plotter. Go to details and set priority. High. Yes. And then we're going to change this one to only the last 2. So we're going to get rid of these, and we're going to do the last 2 cores. So CPU 12 and 10. Okay. Let's kick off number 4. Start. And now these last 2 threads are being used for that last core. This one's free. We're only utilizing core 10 and core 11 through this CPU Affinity. So this is going to give us amazing micromanagement of every single thread on your computer. So I don't have the results yet. It's just the theory and the basic functionality, but this should really help out with our speeds on every single thread that we're using. So with that said, that's again for the task going. Here's one of the details of what's happening, computing tables, and it'll just keep going and explain to you what phase it's in and how it's working. So you can grep all of those logs and put them into a folder or what have you, and kind of do an analysis of how it's going. But this is really cool to be able to micromanage every CPU thread per phase. Not per phase, but per task. So that's kind of how I'm working with Harry Plotter. He's going to be, he does a lot of work online. He's constantly replying to our messages. So I'm going to see if I can work with him to kind of configure it in a way that can get more advanced options and really optimize its work. So I think that's about it for now. Farmer, Swar, Harry Plotter, partitioning. The only other thing I wanted to kind of mention was when you partition the drives, you're going to want to change the drive before you partition it into a dynamic drive. The difference between a basic and a dynamic drive: the dynamic drive allows you to increase and decrease the space on the fly without having to delete the partition before it. So if I wanted to increase partition D and it was a basic drive, I wouldn't be able to increase it because it's bumping into partition E. With dynamic, I can adjust this in real time, and it'll automatically adjust partition E. I don't have to delete partition E. So dynamic, when you create the drives, make them dynamic, because if 235 gigs is not enough to plot, then we just inch it over a little bit, or if it's too much, then we can decrease and decrease with a dynamic drive. So I know I ran through this pretty quickly, but I had already done all of this, and so this is the second time I've been doing it. thanks for the comments. I'm really blown away at some of the comments. It's pretty amazing. I did this channel a long time ago and never really took off, but I'm really excited to keep pumping out some information and ideas that I might have. So with that said, I will chia later.